Hi everyone! Today we're doing Unit 7, Day 6 notes, similarities in right triangles. Okay, so recall, the altitude of a triangle is a segment drawn from a vertex perpendicular to the opposite side of the triangle. It's another word for height. So in this picture here, take a moment and look at that. How many triangles do you see? What do you know about those triangles? So I'm going to answer those questions right now. In the diagram below, line segment BD is the altitude drawn to hypotenuse AC of right triangle ABC. So there's a big right triangle ABC. When you draw an altitude, it's defined to be perpendicular. So you get two more right angles. So there are now three right triangles in the picture. There's a right triangle, a small one, there's a medium one, and then the big one. And this situation creates three pairs of similar triangles. So here's my similarity statement. They're all similar. Now remember from last unit, if you have similar triangles, you can set up proportions. Corresponding sides are proportional. So that leads to this situation here. When the altitude is drawn to the hypotenuse of a right triangle, there are three proportions that can be formed. So to help you figure out the corresponding sides, you first have to figure out which two triangles you have two sides of. So we're going to take our highlighters. So when you're doing a problem, you're going to read it first and you're going to put in the given information. You're going to put in an X or some variable where you're looking for that piece. So in this first picture alone, let's not look at these. So I have a big right triangle. I have the altitude drawn to its hypotenuse. So notice that altitude breaks the hypotenuse of the big triangle into two pieces, which I'm going to call A and B. And in this problem, we're looking for X. Now, these A and B are going to be numbers, and we're going to be looking for X. Or maybe we have this one, and we're looking for that. Two out of these three will be numbers, and then we're looking for the third one. So, first you have to figure out which two triangles you have two sides of. Well, I'm noticing X and A are both on the triangle on the left. So if I highlight that triangle, X and A are on that triangle. Now I'm also noticing X and B are on the triangle that's on the right. So I'm going to highlight that triangle. Do you notice there's double highlighting right here? There's yellow and pink. X is the side of both triangles. So you know how X is kind of going to itself, reflexive property? So we're going to use X twice in our proportion. So again, determine which two triangles you have two sides of. The side that is on both triangles in the proportion is going to be diagonal to itself. So the side with double coloring, the side that's on both, is going to be diagonal to itself. And the other two sides are going to be the pieces of the hypotenuse. So with this situation alone, where you're looking for the altitude, that is diagonal to itself between the other two pieces. And remember, you could set up a proportion like this. All I know is X is going to be diagonal to itself, and it doesn't matter where the other two pieces go. B could go here, A could go there. Just the piece that's colored in twice has to be diagonal to itself between the other two given sides of the big triangle's hypotenuse. All right, let's look at this middle situation. Now I have labeled Y, this is C, and the length of the big hypotenuse is D. Now again, two out of these three are going to be numbers, and one of them only will be a variable. So figure out which two triangles do you have two sides of. So in this case, I see Y and C are both on the triangle on the left. So I'm going to highlight that triangle. Now I see that Y and D are on the big triangle. So I'm going to highlight the big triangle. Now one of those sides is going to have double coloring for the length of the whole side. So in this case, it's right here. This side, this whole side is yellow and pink. So y is going to be diagonal to itself between C and D. And again, C is part of the big triangle's hypotenuse, and so is D. All right, this next one is the same situation, just kind of flipped over that way. It's the exact same thing. So now we have Z, E, and F is going with the big triangle. So I'm noticing Z and E are on this triangle that's on the right. And remember, 2 out of these 3 are going to be numbers, and there's only going to be one variable. Z and F are on the big triangle. So I'm highlighting the big one. And again, Z, this side has yellow and pink. That's going to be diagonal to itself between the other 2 measurements of the big triangle's hypotenuse. And that's how these go. So you just follow these rules right here. Determine which 2 triangles you have 2 sides of. That side is diagonal to itself in the proportion between the other 2 given sides of the big triangle's hypotenuse. All right, let's try some. So number 1, in right triangle ABC, BD is the altitude drawn to hypotenuse AC. If the length from B to D is 12, so I'm going to fill that in my picture. And the length from D to C is 8, so I'm going to fill that in the picture. Find the length from A to D. So that's going to be my variable x. Now, do you notice, yes, we have right triangles. Can we use Pythagorean theorem to solve for x? We're going to try all our strategies. So x is on this triangle. I have 12. I cannot use Pythagorean theorem because I do not have 2 sides of this triangle. Could you start this problem over here? You could solve for an angle. You could solve for an angle measurement. You can use trigonometry to solve for angle C, or you could solve for angle DBC up here. You could do trigonometry. You could solve for that angle. Then you could, once you knew this angle, you could find this angle next to it because together they add up to 90. And then you could use trigonometry to solve for this. So there are different ways to do this problem. If you just want to do one math problem and not 2 or 3 different math problems, you could apply what we're doing today. We have a big right triangle. We have the altitude drawn. There's 3 right triangles. We're looking for sides. You can set up a proportion. So if you figure out which 2 triangles you have 2 sides of, I'm noticing 12 and 8 are on this triangle on the right. And then 12 and x go with the triangle that's on the left. There's always right, left, and big triangle. So in this problem, the one with double coloring is 12. So somewhere in your proportion, 12 is diagonal to itself between the other parts of the big triangle's hypotenuse. So that's your easy proportion. Cross multiply. 8 times x is 8x. And we got to do 12 times 12. 12 times 12 is 144. Solving for x, we're going to divide both sides by 8. So now I'm grabbing my calculator. 144 divided by 8 is 18. So x was AD. It's what it wanted. The length from A to D is 18. I'm done. Put that in a box. So again, you could have done 3 other math problems to arrive at this, or just noticed you can set up the one proportion. All right, let's try some more. All right, problem 2. In right triangle ABC, so that's labeled, BD is the altitude drawn to hypotenuse AC. When you see all of that, that's your hint that you can just simply do a proportion. If D, the length from D to C is 4, so fill that in, and the length from A to C is 12. Now I need to indicate all of this is 12. So I'm putting this little bracket here. You need to somehow indicate from A all the way over to C, that's 12. Find, all right, part A, find the length from B to C to the nearest hundredth. So I'm going to label that X. So here's going to be my work for that. All right, so again, you could possibly do a whole bunch of trig to figure this out, but I'm going to set up my proportions. I'm going to look at which two triangles do we have two sides of. So I notice X and 4 are on the triangle on the right. Do I have two sides of the triangle on the left? I don't have that one, don't have that one. So nope, I'm not using the triangle on the left. So ask yourself, do you have two sides of the big triangle? Actually, I do. I have X and 12. So if you just kind of go through all three triangles, there's only going to be two of them that you have two sides of. So now look for double coloring. Now I know there's double coloring here, but DC is yellow, but A to C is pink. So that we're comparing small triangle to big. They both have line segment BC on them. So X is the side that's on both. That's going to be used twice. It's diagonal to itself. And then the other side of the small triangle is a 4. Doesn't matter where that goes. And then the hypotenuse of the big triangle is 12. So that's how you set it up. Cross multiply. X times X is X squared. 4 times 12. So X squared equals 48. To solve for X, we're going to take the square root. And then it says to the nearest hundredth. So square root of 48. So this is going to be 6 hundredth has 2 decimal places, so I'm making a decision about the 2. The 8 tells me to round the 2 up, so it's going to be 6.93. All right, that part's done. Part B. Find the measure of angle BAC to the nearest degree. I need a new variable. I already used X, so I'm going to continue on and use Y. All right, so BAC, we're looking for an angle. Can we use Pythagorean theorem? No, that doesn't help us find angles. Can we set up a proportion? No, that doesn't help us find angles. The only way to find an angle measurement is by using trig. All right, so you now need to make a decision because angle Y is in two different right triangles. Do we want to use trigonometry on triangle BAD? To solve for Y, the angle, we would need two sides of that triangle. We do not have two sides of this little triangle, so that's not the one we're going to use. Angle Y is also in the big triangle. Do we have two sides of the big triangle? Actually, yes. We have Y. We have 12, and then we just solved for X. So, since I'm going to be using X, I want to go back to my calculator and use a longer value for X. So I'm going to use 6.9282. I'm going up 4 decimal places. All right, so we're focusing on the big triangle. I'm actually going to use like a third color. Here's my reference angle. It's going to be in green. The side that's not highlighted is your opposite. And then across from the right angle is your hypotenuse. So to solve for Y, this Y, we are going to end up using, I got to write my words, so, ka, toa. O and H come from sine. So I need the sine of angle A, well, which I'm going to replace with Y. The sine of Y is going to be my opposite, 6.9282, divided by my hypotenuse, which is 12. Now, to solve for the angle, this is when you press your second button. So we're going to type in second sine 6.9282 divided by 12. So second sine 6.9282, divide that by 12. And now we're going to round this to the nearest degree. So this turns out to be a 35-degree angle. y equals 35 degrees.